Dear students, in today's module, we will be learning binary notation. We have learned it in bit and pieces in different modules, but we have dedicated this module to properly see what is a binary notation, as this will be used in the next modules to store numeric and numeric values. So, before starting the binary notation, you should recall the base 10 or decimal system. You see, when you say 375, so what does it mean? 375. It is a unit place, it is 10th place, and it is 100th place. So you say this is 10 raised to power 0, this is 10 raised to power 1, and this is 10 raised to power 2. Because when you want to translate 375, you say 10 raised to power 2, which means 100 multiplied by 3, which forms 300, plus 10 multiplied by 7, which is 70, plus 10 raised to power 0 means 1 into 5, so it becomes 375. Similarly, in binary numbers, we have the base of 2, which forms 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, and so on. So we will learn it in this module. So in binary numbers, the quantity associated with each position is twice the quantity associated with the position to its right, as we have seen in the previous slide. And how to convert a decimal number into binary notation? So these are simple 3 steps. One is divide the value by 2 and record the remainder. As long as the quotient obtained is not 0, continue to divide the newest quotient by 2 and record the remainder. And now that the quotient of 0 has been obtained, then the binary representation of the original value consists of remainders listed from right to left in the order they were recorded. Let's see an example. So we want to represent 13 in the binary notation. So 13 is a decimal. We want to display it in a binary notation. So we divide 13 by 2. 2 6 are 12. So 1 is left. So this one will go here in the units place. Then we form 6. 2 3s are 6. We form 0, which is here. 2 1 are 2. 1 is remainder, which is gone here. And this one is going upward. 2 zeros are 0. So 1 is remainder, and that one is coming here. So 1 1 0 1. This will form the basically 13 in the binary notation. So let's do some more examples of representing numbers in the binary form. So for example, you want to represent 32 in the binary. So let's see. We divided 32 with 2. So 2 16s are 32, we left with 0. 2 8s are 16, we left with 0. 2 4s are 8, we left with 0. 2 2s are 4, we left with 0. 2 1s are 2, and we left with 0. And we write it in this way. So this will become 1 0 0 0 0 0. So there are 1 2 3 4 5. 2 3 4 5. So these 5 zeros with a 1 to the most right portion, this will be represented as 32. So let's do another example. For example, you want to display 27. So 2 1s are 2, 2 3s are 6, 1 is left. 2 6 are 12, 1 is left. 2 3s are 6, 0 is left. 2 1s are 2, and 1 is left. So 1 1 0 1 1. So this is 27. So let's do another example. We want to see what is 15, the decimal 15 in binary notation. So we can say 2 7s are 14, 1 is left. 2 3s are 6, 1 is left. 2 1s are 1, 1 is left. So writing in this direction 1 1 1 1. So this is in the base 2. So we normally write it 2. So this 1 1 1 is representing 15 in the binary system. So there is another method known as power method, which you have learned somewhere in the start of the course. So we are going to revise this power method as well with number of examples. So for example, you want to display 15. So easiest method of not dividing each and every number starting from 15, you can only see that this is representing 2 raised to power 0, which is 1, 2 raised to power 1, which is 2, 2 raised to power 2, which is 4, 8, 16, 32, and so on. So to represent 15, you just need to put 1 on those slots which can make you 15. So for example, you know that 8 plus 4 is 12, plus 2 is 14, plus 1 is 15, and put zeros in all of the other locations. So this will give you 15. If you want to display 32, you simply go in this direction, and where you find 32, put 1 here and all other zeros. So this becomes 32. For example, we want to display 48. So you know that 32 plus 16 becomes 48. So you need to put 1 1 in all of those and zeros in all others. So this will become 48. Then for example, you want to display 65. So 64 plus 1, all others zeros. So this has become 65. Similarly, for example, you want to display 3. So 2 plus 1 is 3, all others are 0. And if you want to display 255, you need to put 1 in all of these. So that is the maximum number which can be represented with the 8 bits. So if you put 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, that will give you 255. So if we summarize today's module, we have learned how to represent a binary notation using 2 methods. One is also available in your book, which is called division method, and we have also learned a very easy method known as power method.